Okay, so I introduced you to this on Thursday, but I just want to go through the setup of it. Okay, so if you look at it and you go into the graphical calculator, okay, just how you set that graphical calculator up. Okay, so if you search Desmos, you'll get this. Okay, clicking into that, you'll get a screen like so, into the graphing calculator. Remember, on this first screen you get, okay, this will allow you to graph straight lines, for instance, so y equals 2x plus 3, okay, something along those lines, and allow you to see straight lines and allow you to pick up different information from that. Okay, so if you click anywhere on that, you get the coordinate as well. So if you want to see where it crosses the y-axis, for instance, okay, you're able to pick that up. So it's quite good for straight lines as well. Okay, now that's not what we were using it for. So for the trig graphs, if you go to graph settings, okay, you'll get this screen here. Okay, and the first thing you want to do is set it to degrees. Okay, so down the bottom you've got radians and degrees. So we want it in degrees. Okay, your y-axis plus and minus. Okay, so that's your vertical axis, remember. This depends how big your graph is going to be. This depends on how big the amplitude is going to be. Okay, so I'll put 4, -4. Okay, just remember y is greater than or equal to -4. Okay, so -4 is on the y-axis there, and then +4 is on the, above the 0 line. Okay, now on the x-axis, because we are doing trig graphs, okay, obviously our milestones are every 90. Okay, so 360, 720. So if I set that up between -180 and 720, okay, so you see x. Now you can go 0 there, but it doesn't give you it very clearly. Okay, -180 just pushes where that 0 point is a wee bit further right, so you can see it a wee bit more clearly. Okay, importantly, if you put the step here as 90, okay, if you put the step here as 90, it gives you your milestones that we talk about. Okay, so you've got your 0, your 90, your 180, 270, 360, and that continues. Okay, so remember, sometimes we look for these graphs at a point past 360. Okay, so common ones will be 540 or even 720. Okay, so it gives you a 90 every step of the way. So you want to set it up like you see on screen here. The amplitude or the y-axis, okay, these min and max, you need to set it up depending on how big your graph is going to be. Okay, if I go into that and I go up to the top left now and I type y equals sine x, I'll get my sine curve. Okay, so that sine curve we were looking at on Thursday. Okay, remember, what is this actually showing you? Okay, it's showing something that repeats over and over again. Okay, and we'll look at an example question of that either tonight or on Thursday, where it shows a movement in a spring and it going up and down, up and down, up and down. It's that repetition that we can model with these graphs. Okay, remember the sine graph itself, the key milestones. So we've got a start point at coordinate 0, 0. Okay, we've got a coordinate at 0, 0. Okay, so our sine graph, coordinate 0, 0 is where it starts. Okay, goes up to a maximum. Goes up to a maximum at 90. Okay, so when the x is at 90, let's zoom in a wee bit. The x-axis is at 90. The maximum for just sine is 1 when y equals 1. Okay, you see that? So that's the coordinate. Goes to 180 and 0. 270, it goes to a minimum. And 360, it completes one single wave. Okay, now remember it repeats itself, so it continues on past that 360 point, but one repetition of your simple sine curve is between 0 and 360, and we've got 5 key milestones there. Start, max, where it cuts 0, minimum, and where it finishes. Okay, so that's your 5 key milestones on the screen for your basic sine curve. Now that's your start point for anything that we draw out. Okay, that's your start point on the screen there for a sine curve. So as soon as you see sine, even if you just want to put in the side of your page where your start points are, okay, and then we can add to it whether we're changing the amplitude, whether we're changing the vertical movement, okay. This is our start point every time, or whether we are flipping that, okay, whether we are putting a negative and it flips that in its head. Okay, so let's just go through a couple of those put on that said there. Okay, if we're talking about the amplitude, we're talking about a form of the sine curve where there's a number in front of that sine. Okay, so there's a number, let's try and move this out of the way. There's a number in front of the sine. So over on the left, I've got 4 sine x. Okay, that number 4 becomes the amplitude. It becomes the height of it. Okay, now the key milestones are the same. Start point is 0, 0. The maximum is still when x is equal to 90. It still cuts the x-axis at 180. Still hits a minimum at 270, and it still completes one full curve or one full wave when it hits 360. Okay, so we've not changed the milestones in regards to where it starts and finishes. All we've done is make that bigger. Okay, now if I put y equals sine x just to compare, you can see the difference in amplitude there. Okay, you can see the maximum, instead of being at 1, is up at 4, minimum, instead of -1, it's down at -4. The other ones we looked at, okay, y equal to sine x, we put a number after the x, okay, so we had plus or minus and then a number. Okay, so if I remove y equals sine x and just focus on this one, we've got sine x, so we've still got the same amplitude. Okay, so it still goes up 1, down, down 1, up, down. Okay, the milestones still starts when x equals 0, maximum still when x equals 90. Okay, minimum still when x equals 270. And the finish of one full wave is still when x equals 360. Okay. What it's done by adding 2 is just moved that up the y-axis by 2. Okay. If I take away 2, it goes down the y-axis by 2. Okay. Key milestones are still every 90 degrees. 90, 90, 90. Okay. Okay, so going back to just sine x, one full wave to 360. Okay. The other type of graph we looked at was when we put a negative in front. Okay, so if I put a negative in front of that sine, it flips on its end. Okay, so take that negative away, you can see instead of the maximum being at 1, I've got a negative there, the maximum's, the minimum is now at 90. Okay, it flips it up. Okay, flips it. Okay, so that's always going to be our start point. When you're drawing out, okay, when you're drawing a graph out, that's going to be our start point. Any questions on that. Why is this disconnected? Happy days. Don't know what happened there. Okay, so how does he appear in a question? So you'll be asked to sketch, or you could be asked to sketch one of these. Okay, and by sketch means you won't be given any graph paper or anything like that. You'll just be given plain paper. Okay, so they're not looking for it to be perfect, but they're looking for you to identify all the key aspects of that graph. Okay, so your key milestones, your maximum, your minimum, okay, and where it starts and finishes. Okay, so the graphs that we've looked at so far, y is equal to sine x. Now you won't obviously get this, but this is always going to be your starting point. Okay, so you always need to label up the axis. So the x-axis is your horizontal, your y-axis is your vertical. You need to identify where the 0 point is. Now the 0 point is always where these two axes cross over. Okay, so where your x-axis crosses your y-axis. Okay, at this point here, that's always 0, 0 coordinate. Pardon me. Okay, that's always going to be coordinate 0, 0. Okay, now for the sine curve, that's your start point. Your other key milestones, 360, halfway is 180, and then 90 and 90. Okay, if I zoom in a wee bit, 90, 180, 270, 360. Okay, my key milestones for a basic sine x. So this is your start point. Maximum 1, got a wee dot, crosses the x-axis again at 880. Okay, minimum when it's 270, it's going to be -1, could be here. Okay, and again it finishes at 360. So a sine curve starting at 0, 0. Okay, and then the key milestones. Okay, so you need to identify all the important parts. Okay, so you need to number, make sure the numbers are on the y-axis, make sure your milestones are on the x-axis, make sure your axes are labelled as such. Okay, if you get asked to sketch that, now you will not get given graph paper in the exam, it will just be on paper, so it doesn't have to be perfect. Okay, what you should avoid is a graph that looks like that. Okay, too pointed, you want it to be nice and curved. Okay, so graphs, the type of graphs we looked at on Thursday. Okay, in the form y equals a sine x. Okay, that a is your amplitude or your height. Okay, we also looked at in the form y equals a sine x plus b. Okay, that a is still the amplitude, and that b was movement on the vertical. Okay, y-axis. Okay. The only other one we did was when it was a negative and we flipped it on its side. Okay, so that was the sine wave that we looked at. You're starting at 0, 0, Okay, and then you're thinking about amplitude movement on the vertical. We also looked at y equals cos x. Okay, now the face of it, it looks very similar, but the milestones change. Okay, the milestones are changed. At 0, when x is equal to 0, y is at its maximum. The wave is at its maximum. Okay, so this is your basic cos x graph. So when x is equal to 0, y is at a maximum of 1. Cuts the x-axis again at 90, hits a minimum at 180, cuts the x-axis at 270, and then finishes at 360. So it goes positive, negative, negative, positive. Okay, if we think about it as quadrants, and we'll come back to that term later on. Okay, so 0 to 90 is your first quadrant, all positive, 90 to 180, all negative, 180 to 270, all negative, and 270 to 360, all positive. Okay. Pardon me. The form of it, again, how we write it out, is the same rules apply. Okay, so if I've got a number in front of that, that's going to change the amplitude for me. Okay, so you see that red line, the maximum's higher, the minimum's lower, the amplitude's changed because I've got a 2 in front of it. Okay. Likewise, I can move it up and down the y-axis, okay, by adding 1. So that blue line, let's get rid of the R2, that blue line shows the start point being moved up 1, okay, where it crosses what would have been 0, that's been moved up 1, okay, 180, moved up 1, 270, moved up 1, 360, moved up 1, okay. Basic cost graph, put a negative in front of it, flips it on the top, okay, it flips it upside down. So the start point becomes -1, when y equals -1, x is 0. Still cuts the x-axis at 90. The maximum now becomes 180, cuts the x-axis at 270, and then it still finishes at 360, but this time it's a negative. Okay, it's at a minimum. Okay, so that's our milestones for the cost graph that we looked at. Okay. Likewise, if you're seeing it in the question, okay, again, we'll have to sketch this out. Okay, so we're sketching y equals cos x. Again, you won't get given graph paper for this, guys, so it doesn't have to be perfect, but it has to be decent. Okay, your 0 point, your origin, okay, it's 0, 0. 0 on the x-axis, 0 on the y-axis. Okay, your key milestones, 90, 180, 270, 360. This time, starts at 1, cuts 0 at 90, minimum -1 at 180, cuts 0 at 270, and then a maximum again at 360. It doesn't have to be a work of art, but it needs to show a nice curve, and it needs to show the key information, maximums. Okay, it needs to show minimums, and it needs to show the x and y axis. Okay. Similar to last time, y equals a cos x, amplitude, y equals a cos x plus e, okay, in the form of amplitude and movement on vertical y-axis. Okay, and we went through a bunch of examples. Okay, the videos is now there. Okay, so tonight we're going to add two more things to this. Two more things that could come up. Okay, two more things that can come up. Before I go on, any questions on that, guys? Anyone want me to do anything? Good. Nice one. Okie dokie. Right. Okay. So tonight, first thing we're going to look at is graphs in the form of y equals a sine bx or y. Okay, so in the form of y equals a sine bx or y equals a sine bx plus c. Okay, so where have I positioned, in this case, a character? Okay, but that character represents a number, so we're going to be putting a number in front of that x. Okay, I'm going to be putting a number in front of that x. That a is still going to be amplitude. That doesn't change. That plus a number, okay, still going to be movement on y-axis. Okay, the new number that we've put on it, okay, that b, that's going to be how many waves. Okay, and 360 degrees. Okay, so up until now we've only been working with one wave in between 0 and 360 degrees. Okay, if we put a number in there, whatever number that is, that's how many waves are going to be, full waves start to finish, are going to be in between 0 and 360. Okay.
So is that, sorry Dan, is that a repeating sequence then?
Yes, still going to be a repeating sequence. Good question. We'll look at that in Desmos in 2 seconds. Okay.
Okay, thanks.
So if I've got, I'm not going to draw this out, but if I've got y equals sine 2x, okay, that's telling me there's going to be two full waves, okay, in 360 degrees. Okay. Likewise, if I've got y equals 4 cos 3x, that's telling me amplitude is 4, and there's going to be 3 full waves and 360 degrees. Okay. So the important part for this, every key milestone now happens Okay. That 90 divided by the number of waves. Okay, let's have a wee look at that, go through some examples and see what I'm meaning. Okay. Okay, standard wave. No, that's not standard waves, that's upside down. And let's start with sine. Okay, standard sine wave, start at 0, finish at 360, one full wave. Okay. If I put 2 in there, see what it does? Just doubles that. Okay. So the milestones for one full wave still starts at 0, 0, but they've now compressed. So you get one full wave in 180 degrees, and then your second full wave in between 180 and 360. Okay, so you've now got 2 full waves in that same period. Okay. So as Sharon was saying, that repeats forever and ever and ever. Okay, so we're modelling repetition. Okay, we're interested between 0 and 360, or if the question asks for it, 540, 720. Okay, but mainly between 0 and 360. Okay, that number, how many waves between that? Okay. Likewise, y equals cos x. Okay, all your recognisable milestones. We put 3 in front of that. Okay. Now see the milestones now happen every 30 degrees. Okay, we've now got 3 full waves in between 0 and 360. Okay. One that I'd look out for and be careful of comes up. Okay. So when you've got y equals sine x, okay, and they do half a curve. Sorry, wave. Keep calling it curve. They do half a wave in between 0 and 360. Okay, so if it's half, then your milestones actually double. So instead of being every 90, your maximum now gets pushed out to 180. Okay, then crosses at 360, and then that continues. Okay, to get one full wave between 0 and 720. Okay, that's a tricky one that they might catch you out with. Okay, so I've written 0.5 there, but they might sometimes write it's a half. Okay, just to be awkward. Okay, just to go back so we can see it nice and neatly laid out. Okay, y equals sine 2x. Starting at 0. Okay, you've moved your milestones. You've done 90 divided by 2. Okay, so your milestones are now every 45. So instead of your maximum being at when x equals 90, your maximum becomes when x is equal to 45. Okay. Minimum, instead of being 270, 270 divided by 2 is 135. Okay, so your milestones are every 45 now. So you're getting one full wave between 0 and 180. Second full wave between 180 and 360. Okay. Now if I add on to that, still does the same thing, moves it on the vertical. Okay, so I've just added 1 to that, so nothing's changed with the amplitude. Amplitude's still the same. Every milestone is just moved up 1. So your start point, instead of being 0, 0, is moved up 1. Okay, the maximum, instead of being 45, 1, it's now 45, 2. Okay, minimum, instead of being 135 minus 1, it's gone up to 135, 0. Okay. If we do change the amplitude, okay, you can go into settings and set this up. So y-axis minus 4. Okay. Nothing's changed really about what we do. Okay, so that 3 sine 2x, that 3 is the amplitude. Okay, so that makes from start to the maximum 3, okay, up the y-axis. Once we hit 0 again, from 0 to the bottom, it's still 3, okay, 1, 2, 3 to the bottom there, okay, up to 3, down 3, okay, up, blah, blah, blah. The 2x is your how many in the 360, and your plus 1, we've moved all the milestones up 1. Okay, so those two things we learned about last week haven't changed. The amplitude and moving it up the y-axis haven't changed. Okay, what we've added is just how many full waves do we get in between 0 and 360. Okay, let's sketch that, because that's what you'll be asked to do. Okay, you will not be given Desmos. Okay, let's sketch a couple. How's that 40 minutes already? My God. Example. Sketch y equals 4 sine 2x. Okay. Remember, we write in between 0 and 360. Now all this is doing, this part is setting your limits for your x-axis. Okay, so all that's doing there is your limits for x-axis. Okay, so that's what it wants you to show. 0 is the start, 360 is the finish. Okay, let's go through the main points. That's going to be your amplitude. It's going to be how many waves. Okay. I asked you, or the way I like to do it, and it's completely up to you if you do this. Okay. I like to, over the right hand side, just do a wee rough sketch just to get my sort of head into what it's asking me to do. So when I say a rough sketch, okay, either just say rough or original, whatever you want to do. Start with just a normal sign. Okay. You know where your milestones are here. Okay, so we've got 5 key milestones, all at 90 degrees. Okay, so you've got in between 0 and 360. Okay, your original, it's going to be 1 wave. Now you just go through step by step everything in that question. Okay, so step 1, okay, we're changing the amplitude. So the maximum and minimum just becomes 4. Every other milestone we're just keeping the same. Okay, so far all the milestones have just stayed the same. So between 0 and 360, we've changed the amplitude. Step 2, we want to take into account this 2. Okay, so there's going to be 2 full waves. Okay, so our milestones now change from 90 to 90 divided by the number of waves, so 90 divided by 2. So there's going to be a milestone every 45 degrees. Okay, so if I'm roughly sketching that, here I've got 4 and -4. I've got my limit, which is 360. And I've got 180. Okay. I've now got a full wave in between 0 and 180. And I've got another full wave in between 180 and 360. Okay. So if I was to draw that roughly, okay, it's very rough. But now I've got in my head what I'm sort of trying to get, and now I can go up and confidently draw. Okay, now I've got every step, and I've written out every step, and I've taken a wee bit longer than maybe you would hope to. Okay, but at least I've methodically gone through that, and I can see and I can picture every single step. Okay. Now the better you get, you can skip, okay, or you can jump or whatever you want to do. Okay. But at the start, once you get your head in it, just go through methodically. Take the rough and actually draw that out. Okay. So it's between 0 and 360. That's your x-axis, that's your y-axis. The amplitude we've got is 4, -4. Okay, and then let's find our milestones. So halfway between that is 180. Okay, halfway between that is going to give us 90 to 70. Okay, but I've worked out that the milestones are every 45. So I actually want another wee mark here and then here. Okay, so 45. That'll be 135. Okay, so I'm adding on 45, 90, 135, 180. 180 plus 45 give me 225. 225 plus 45 is 270. Plus 45 is 315. Okay. That along the x-axis is now all my key milestones. Now my milestones haven't changed. Sine starts at 0, 0. The maximum's the first milestone. Now the maximum is changed. Instead of being at 90, it's now at 45. So my maximum is here. It now crosses at 90 instead of 180. I've got a minimum 135. And then the wave finishes at 180. That's one full wave. So just drawing that in. That's one full wave. Exact same process. Milestone, 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 milestone. Draw it in. Oh, all about repetition. Try and get it as curvy as possible. Okay. Not the best looking, but it's got every single bit of detail that I need there. Amplitude, key milestones, x and y axis. Start point, finish point, how many waves, blah blah blah. Okay, it's shown me everything I need there. Okay. Any questions? Pardon me. Cool. Okay. Example 2. Y equals 6. Right, let's leave it at that. Sign again, but that's fine. Okay, so we're just adding that extra wee bit there. Okay, so we're just adding that +2 at the end. Okay, everything's still the same as what we've been working with. So amplitude, vertical movement, and that's how many waves. Okay. Of course, the question will give you your limits as well. So 0, x 360. Okay, so that's just saying where you're starting and where you're finishing. That's all that wee bit says. Okay, so don't let that wee bit put you off. Okay, or scare you, or whatever it may be. Okay. Rough working, or whatever you want to call it. Okay, so take it over to the right hand side. Make sure you separate it. Okay, make sure you really cut that page up. Rough working. What's it telling me? Okay, so amplitude. It's going to equal 6. Okay, so our max equals 6. Our start, finish equals 0. Our minimum equals -6. Okay, now this is just the first step and I'm just going through it methodically again. Okay, so going from left to right on that equation, the amplitude is 6. So I'm going to write the maximum minimum now, and when I get to the vertical movement part, I'll revisit that. Okay. Second part, how many? Okay, so number of waves equals 3. Okay, so milestones is going to equal 90 divided by 3. So there's going to be a milestone every 30 degrees. Okay, so that's the first bit. And then the last bit is the vertical movement. Okay. Now it's telling us +2. Okay. So the vertical movement is equal to +2. That means everything on the every milestone we've got moves up the y-axis by 2 places. Okay, so every milestone we've got on the graph, okay, it's going to move up the y-axis by 2 places. That means the new maximum is going to equal 6 plus 2. So new maximum is 8. Your start finish 0 plus 2. We'll start at 2. And your new minimum Instead of being at -6, it's -6 plus 2. It's going to be -4. Okay. So that's your key points there. So we're going to take that information and we're going to draw a graph. Any questions with what I've done there? Okay, so this bit becomes obsolete now. Okay, the important parts are max, start finish point, and minimum, number of waves for the key milestones. Okay. Let's draw a graph out. Okay, let's mark it up. Y-axis, X-axis. Okay, that's going to be 360. Okay, first thing I want to do, well, first thing I've done is mark up my 0 and 360. Okay, so that's my limitations. Okay, that comes from this wee bit here. Okay, between 0 and 360. Okay, so that's my limits. So I've got on my x-axis, start point is 0, finish point 360. Now what else did I find out during my rough working? My maximum is going to be 8 and my minimum is going to be -4. And my start finish point is going to be 2. Okay, so that x-axis is where y equals 0. Okay, so when y equals 2, okay, that's going to be my new start finish point, and when y equals 2, 4, 6, stay there, that's going to be my new maximum. Okay, -4, 2, -2, -4 is going to be my new minimum. Okay, now the easiest thing to do at this point would be create a new horizontal line. Okay, where you're going to be start finishing. Okay, now you can't make this a solid, but you can make this a wee dotted line. Okay, now I've done that because it's not even straight, is it? No, it's a disaster. Oh, there we go. Okay, I draw a dotted line? No. Of course I can't. Okay, so best you can, draw a dotted horizontal line for where your start finish is going to be. Okay. Now remember, why is that line important? Okay. Well, for a sine graph, that's going to be our start finish, but it's also going to be where it cuts through. Okay, so they're milestones where it usually cuts through the x-axis. That's been moved up to. Okay, so that allows me to find out, okay, what point it's going to go through that line, okay, when it's going to act on that. Now, next thing I want to do, I've got my max and my min and where my start finish is going to be. I want to indicate where my milestones are going to be. Okay. Don't take too long in these graphs. Don't measure it to the finite minute millimeter. Okay, get 360, half it, half it, half it. Okay, so that'll be 0, 90, 180, 279. So okay, so that's going to give me milestones of 30 now. So I'm just going to write that on 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, lot of milestones, 330 and 360. Okay, so every 30 degrees in between 0 and 360, we've got a milestone. Now every full wave has 5 milestones: start finish, maximum where it cuts the x-axis, minimum where it finishes. Okay, now remember everything's been moved up to. So our start finish, or sorry, our start is going to be starting here. Our next point is going to be a maximum. It's going to be at 30. Try and indicate that as best as possible. Okay, it's going to get quite tight. Then a sine graph comes down, usually to cut the x-axis as its next milestone, but that's been moved up vertically by 2. So 60, it's cutting the 2 line, that new horizontal you've done. Okay, so that's something we didn't discuss on Thursday, so that might be new. Okay, 90, it's going to hit its minimum. And then at 120, it's back up to 2. Okay, that's one full wave. It's quite hard to draw on this, so bear with me. Okay, so it's not the perfect wave, it's not got the perfect width there, but it shows all the key milestones. That continues to 360, so they want you to draw 3 full waves, so it's continue as is. At 150, it's going to be max. 180, it's going to cut through the 2. 210, it's going to be down at a minimum. 240, yeah, new maximum, new minimum, and then finish. Okay. Push. Okay. So you've got 3 full waves. Okay, so if I just draw lines in just to separate them, okay. These green lines are just to indicate where the waves start and finish. Okay, so quite a lot going on there. Okay, quite a lot going on there. But if you just take it one step at a time, that's all I'm saying. Every time we do any question, take it one step at a time and break that question down. Okay. Incredibly, that's been an hour. Okay, so I'm going to give you a wee question to do, then we'll take a wee 5 minutes. So, sorry, if anyone's still copying that, give me a wee shout. Okay. Say y equals 2 cos. Okay, and we'll go for 2x plus minus. So I've changed a couple of things there. So the cos graph we're using, so think about the milestones of a cos graph. Okay, I've given you an amplitude of 2, and I've given you 2 waves in that 360, and I've given you a y movement of -1. Okay, want that between 0 and 360. Okay. Have a wee go at that. So that should take you maybe 5 minutes. Okay, maybe 10 minutes. and then take a wee 5-minute break in the back of that. Okay, so if we come back together at, let's say, 7:20, okay, and we'll move on. Okay, so come back together at 7:20, have a wee go at that. Okay. Resume recording helps. Okay, so what's it asking you? What's it looking for? For things I'm picking up, okay, between 0 and 360. So all that's doing is just setting that limitation. So it's just starting at 0, finishes at 360, and we need to work out what happens between the rest of it. Okay, now step by step going through that, we've got an amplitude, okay, of 2. Okay, we've got our cost graph. Okay, that means when x is equal to 0, we've got our maximum. It goes down across the x-axis, down to its minimum. Okay, then it starts going back up and it finishes on a maximum as well. So it goes maximum to maximum. Okay, that's what we're looking for in a cost graph. Okay, we've got our new part of it. Okay, so we've got 2 full waves in between 0 and 360. Okay, and then we've got the -1, which is our vertical movement. Okay, so taking all that into consideration, okay, trying to draw that up. Okay, quickest way, let's have a wee look. Quickest way of doing this. Cos 2x -1. Okay, so oops. Let's have a wee look at this. So minus. Okay, so what have we got here? Okay, some important things we're picking up with. Firstly, we spoke about the amplitude. Okay, so the amplitude would just have a maximum at 2 and a minimum at 0. A maximum at 2 and a minimum is -2. Okay, but that's been moved vertically downwards. Okay, so every milestone we've moved it vertically downwards by 1. Okay, so instead of having a maximum at the start of 2, we've got a maximum of 1. That then goes down to a minimum of -3. Okay, instead of -2. Okay, so we've moved that down. Now our milestones are occurring at every 45 degrees. Okay, so every 45 degrees we've got a milestone. So the maximum at the start, the milestone at 45 degrees is where it cuts the -1. Okay, so I'm hoping that you've put a wee horizontal line with -1 shown. Okay, so if I add in just a horizontal line there just to show you that. Okay, so -1. Okay, that's where it cuts there at 45 degrees. So that would give you 45 degrees in there. Okay, 45 degrees. At 90, we've got our minimum. At 135, it's cutting through at -1 again. And then it's finishing one full wave at 180. Okay, that repeats between 180 and 360 again. Okay, so the key things I need in your sketch is that X and Y axes are labelled up. Okay, I need a maximum at 1. I need a minimum at -3. Okay, I need each milestone to be 45 degrees apart. Okay, and this part here is important. Okay, this milestone here at 45 degrees and at 135. Okay, that's where it's cutting the -1. Okay, so in a normal cost graph, that's where it would cut 0, but we've moved that milestone down by 1. Okay, Any questions on that? Anyone not get that or way off?
No, I wasn't quite off. I did the 45, worked that out. I've got the same similar graph, but it didn't take it down to -3.
Okay, so you're getting there though. So
So
you're going through.
the maximum I did a 1. The minimum is where I got confused.
Okay, okay. Did you do the sort of rough working at the side and sort of go step by step through it? Personally, I find that helps sometimes. Okay, it takes a wee bit longer, but until you get fully up to speed, it sort of helps. So, like, so I would have taken that amplitude. I would have max equals 2, min equals -2. Okay, but we've got vertical movement. Okay, of -1. So that would take the max. And the min. Okay, just writing it out like that instead of drawing it straight away just gives you a wee bit of something to grab onto. Okay, especially at the start, just starting to draw these out. Okay, hopefully that helps. Okay, so last part of this, and this is the one that catches you most people out. Okay, simple reason it's very similar to another format. Okay, but we're putting brackets in it, and now those brackets change things. Okay, so graphs in the form y equals a sine bracket x plus b, and y equals a cos bracket x plus b. Okay, when there's a bracket involved, okay, it means we're moving it along the x-axis. So we're moving it to the left or to the right. Okay, so where our start point 0, 0 for the sine graph, if we move that to the right, it moves the coordinate, the x coordinate. Okay, so it doesn't move the y coordinate. We're not doing any vertical movement. Okay, we're solely focused on that movement along the x-axis. Okay, so let's have a wee look at that. So what we're looking at, A, still the amplitude. B in this case is movement along x-axis. Okay. Look out for the brackets. What the brackets are telling you is we're adding it directly to x. Okay, we're without the brackets when we're adding something on. Okay, we're adding it to the full cost curve and we're moving it up and down. Okay, with the brackets, we're moving it along the x-axis left and right. Okay. Important thing is counterproductive. It's counterintuitive. Okay, so this won't mean anything to you yet, but if b is positive, so if that number in there after the x is positive, it moves the graph left. Okay, if b is negative.
Can I just ask, when you say moves left, why is that? Is that similar to the bearings with the degrees moving from north to around the
No.
360 degrees? No,
Nah.
nothing to do with that, though. Okay.
May make more sense when we draw it out. Okay. So when you see any trig, get bearings as far away from your head as possible.
All right. Okay. Yeah.
For simple fact, we'll look at something later on, hopefully tonight.
Okay.
Which, when you compare it like for like with bearings, tends to confuse. Okay, so that will mean something later on. Okay, so don't think bearings when you're thinking about trig.
Okay.
All right. In this form. Okay, so why, when it's positive, does it move it left? Honestly, there is an explanation, but it's not worthwhile knowing. It's the honest answer there.
Yeah.
Okay, so all your milestones then. Okay, so writing out what I'm saying. What it's adding on is going to move your milestones by that number. Okay, so let's just go through an example. Okay. Y equals 3 sine x plus 20. What people tend to mix up here is sort of movement with the vertical as well, but the number in the brackets tends to be a lot bigger, so it would be daft to move it, especially in an exam situation, by that up and down on the y-axis. Okay, it just wouldn't look right. So when it's got something like plus 20, plus 30, plus 45, okay, you immediately think, okay, that's going to be on the x-axis, okay, because the x-axis we're working between 0 and 360. Okay, so in the form, you've got your amplitude, your sine or cos, and then your bracket x plus. Okay, it will always give you the limits, so 0, 360. Okay, and then you're just drawing that out. Okay, so again, I would do rough sketch, just so it's in your head. Rough sketch, got a sine, got 0, 360, 1 minus 1. Okay, our amplitude's changing, so our max, oh my god, max is going to be 3, our minimum is going to be minus 3. Okay, and then all our milestones of 0, 90, 180, 270, 360 are going to move by this plus 20. Now that's going to move it counterintuitively to the left. Okay, so this positive means we're moving it to the left. Okay, so all the milestones are going to move to the left by 20 degrees. Okay, so just very quickly, just noting down a couple of things. Okay, so it's still going to cross the x-axis at 0. We've not changed it in the vertical at all. But everything's going to move it by 20. Okay, let's draw that out. Okay, so x-axis, y-axis. Okay. We want the graph in between 360. Okay, so let's do 360. Our normal milestones is going to be 90, 180, 270, 360. Okay, so just drawing our normal milestones in. Okay, and then we're drawing our minimum and our maximums in. In this case, it's going to be 3 and negative 3. Okay, so that plus 20 is moving everything 20 degrees to the left-hand side. Okay, so we go to our milestones. So our first milestone is 0, 0. Okay, that becomes minus 20, 0. Okay, so it doesn't change in the y-axis, it becomes minus 20 and 0. Okay, our 90 degrees, we're moving to the left 20, so that milestone, okay, becomes 70. 180 moves 20 degrees, becomes 160. 270 becomes 250. 360 becomes 340. Okay. Now what happens at those milestones doesn't change. So instead of starting at 0, 0, it's starting at minus 20, 0. Okay. The first maximum is going to be there. Okay. That's going to be 70 on the x-axis and 3 on the y-axis. Okay. It's then going to cut through the x-axis at 0, 160, and the minimum is going to be when x is equal to 250. Okay, minus 3, which is about here. Okay, and then it completes at 340 instead of 360. It's moved along. Okay, just drawing that in then. Try and make it as curved as possible. I'll get something along those lines. Okay. Now, what you need to be careful of here is this, your limits. So it's asking us to draw it in between 0 and 360. Now we've drawn it in between minus 20 and 340. Okay, which is fine for this current position. Okay, but we need to finish at 360 because that's what the question is asking for, and we need to start at 0. Okay, so this bit here isn't actually needed. Okay. And then at the end, you're actually wanting to extend it. Okay. So it's hitting that 360. That looks a wee bit odd there, it doesn't look the best. Okay. I've drawn a wee dotted line there of red to try and make that level the same. Okay, so where that crosses that y-axis, where it crosses 360 is going to be the same height. Okay, if you think I'm just moving that along. Okay, so we've sort of snipped that. Okay, snipped it on the left hand side and then extended it on the right a wee bit. Okay, now you don't have to work out where that crosses, okay, or where it finishes. You don't have to work that out. So these sketches don't have to be pinpoint perfect, okay, but they need to highlight the main bits. The main bits are your maximum, your minimum, where it crosses the x-axis. Okay. Maybe draw that wee bit of a better sketch. See if it works a wee bit better. So if I do y equals 3 sine x plus 20. limits. Okay, you can see everything is moved along 20. Okay, so what I was trying to explain at the end there is it wants you to start at 0. Okay, where it's cutting there. So it doesn't quite start at 0, it's starting there. And then it's extending a wee bit past. Okay, that's the position the sine graph would normally finish at, but we're extending it a wee bit. Okay, so that there is your 340.
So you don't have 3 waves in that, and then no, just 1 wave.
That's the amplitude. So if the number's before the sine or cos, it's your amplitude.
Right, okay, yeah.
Okay, so that's a good point to bring up though, Sandra. When it's asking you to move it along the x-axis, it will never ask you to do multiple waves as well. Okay, so it will never ask you to do multiple waves. Now I don't know when that is, but it will never ask you, okay, to overcomplicate it. So if we're moving it along the x-axis, you know you're only going to have to do 1 wave, and it's going to be the amplitude you're changing. Okay. Example 2. X plus 30. Okay. And this time, I'm wanting us to think about it between 0 and 540. Okay. So this doesn't necessarily have to be 360. Now there's our basic wave is still going to be 1 complete wave between 0 and 360. But remember, these just repeat over and over again. So every time you go 90 degrees, okay, you're getting another milestone. Okay, so we can go back right up to 540. So 360, 450, 540, 630, 720. So we can go 90, 90, 90, 90. Okay, so it might ask you anything up to 540 or 720. Okay. So let's go through it. That 4 in front of it is going to be our amplitude. Okay, so how high it's going to be. Okay, and then that plus 30 is going to be movement along X. Okay, or horizontal movement. So if I go over, put some rough work together, just draw out my basic cos. Okay, 1, -1, 360, 0. Okay, normal cos X, we've got a milestone every 90. Okay, so that milestone is going to be the start, it's going to be its maximum, it's going to cut the x-axis at 90. This point, it's going to go to a minimum at 180, cut the x-axis at 270, and then reach a maximum again at 360. Okay, now what are we changing compared to the original? Okay, so we've got an amplitude of 4. Okay, so amplitude is going to give a max of 4 and a minimum -4. Okay, and then our x plus 30 is a positive, so we're going to go left again. We're going to move our milestones by 30 degrees along to the left. Okay, so that's just a wee rough sketch out the way of my main answer, just a wee reminder when I'm going through the drawing so I don't miss anything. Okay, go to our main drawing. Y-axis, x-axis. Okay, so 0. 0 is always the point where the two axes cross. The axes do not move. Where the axes cross, where the y line and the x line, the vertical line and the horizontal line cross, that is your 0, 0. That's your origin of your graph. Okay, everything stems from that point. So that horizontal and vertical line don't change. That's your 0 point. Okay. I'm going up on the x-axis to 540 this time. Okay, so we need to find, say here, it's going to be 360, it's going to be 180, 90 to 70. Okay, and then I add on 90 every time as well. Okay, so that's our standard 90, 180, 270, 360. Okay, but it wants us to go to 540, so we add on another 90, taking us to 450, and then we add on another 90, taking us to 540. Okay, we park that to one side for a second, and we just look in between 0 and 360 and focus our attention there. Okay, now we know the amplitude is going to be 4, so our maximum is going to be 4, negative 4. Okay. And our milestones have moved to the left by 30 degrees. So all our milestones that we've written out, 90, 180, 270, 360, 450, 540, they all move 30 degrees to the left. Okay, let's use a different colour. Okay, that's going to be 60, 150, 240, 330, just continue, 420, 540 is 510. Okay, so in blue there is our new milestones. Now you could also do start one, which is minus 30 as well. Okay, just as a wee reminder there. Now what normally happens at the milestones? Okay, well, we know for a cost graph, which is the shape that we're working with, our maximum is at our start. Okay, so we start at maximum. In this case, it's minus 30, so we've got a maximum at minus 30. It then goes down, downward slope, okay, where it crosses the x-axis normally at 90, but we've moved that to the left by 30, okay, so it crosses the x-axis at 60, approaching or going down to a minimum at what will be 150. Crosses the x-axis again at what will be 240, and then reaches a maximum at 330. 330. Okay, so that's one full wave. Okay, that's one full wave that we've moved by 30. Now, it's asking us to continue. So because it's asking us to continue, those milestones start again. So we've got at 330 a start point. Our next milestone, moving by 90 degrees, okay. is where it's cutting the x-axis. Okay, and then at 510, it's going to be hitting a minimum. Okay, so we continue that on. Then after 510, it's going to start continuing up, and we're going to reach 540 and stop there. Okay, so we've got a milestone which is a minimum at 510. But remember, the limits is between 0 and 540, so we need to continue that a wee bit further. After that minimum, it starts to rise again. Okay, so it rises until it reaches 540 and then it stops. Okay. Remember at the start, it's asking us to start it at 0. So this bit here, don't need. Okay, so that's your graph. Okay, did I lose anyone? Okay.
So is that 2 waves or just one complete one?
There's one complete and then another half. Okay, so remember there's a milestone every 90. So between here and here, there's a complete wave. Okay, so between here and here, there's a complete wave. And then it continues on for another half wave.
So the 5 milestones is one complete wave.
Yep, so every 5 milestones, we've got a complete wave.
Yeah.
Okay, but it's asking us to continue for another, essentially 3 milestones. Okay, to complete another half. Okay. Okay, I'll do one more example. If anyone still needs to copy that, give me a wee shout and I can go back.
If you've sketched it out on the exam paper, does it really matter if you don't scrub the -30 ounce? You know where you're drawing that?
Good question. They'd be very, very mean to remove a mark for you. I would say no, but I will double check that. I can't imagine they would. Okay, as long as you've got, make it clear, you know what your limitations are, but you're using that just as a guidance aspect of it.
Because it is part of the equation, isn't it?
Yeah. Yeah. Okay. So we'll do y equals 4 sine x minus 25. Okay. What do we see here? Amplitude again. Okay, it's a sine graph. So we know normal sine graph starts at 0, 0. Okay, but we're minus 25 this time. Okay, so it's movement on the x-axis. And we're going to the right. Okay, so negative number there means we move to the right. So remember, it's counterintuitive. Negative, we're moving right for whatever reason. Okay, we'll do this between 0 and 360. Okay. Then, just to be rough, so normal, just draw out my normal, okay, and then look at what the changes are going to be. So the amplitude 4. Okay, so our max is going to equal 4, our minimum -4. Okay. And then all our milestones are going to move to the right by 25 degrees. Okay, so I would draw something out like that just as a reminder so I can scan it over and just see if I've picked up everything. Okay. God's sake. X, Y, maximum 4, minimum -4, between 0 and 360. Okay. So 0, 90, 180, 270, 360. Okay, all our milestones move 25. Okay, move by 25 degrees. So our start position moves by 25 degrees. Our first main milestone moves by 25 degrees. So that'd be 115. Okay, second milestone would be 205. 295. Okay. And then you can put it on just for understanding, okay? But again, remember, you don't have to do it because your limit's going to be your 360, okay? But you can put 385 there just as a sort of to focus your ideas to see where it's going, okay? Sine graph starts when y equals 0. So we're going to start here where it's x is 25. It's going to peak at 115 instead of 90. It's going to cut the x-axis at 205 instead of 180. It's going to come down to a minimum, 295. And then it's going to finish a full wave at 385. Okay, so drawing that full thing on. Okay, we get shaped like that. Now, what are we missing? So we're missing a wee bit at the start from 0 to 25. Okay, and we've actually got a wee bit too much at the end there. Okay, since it's just a sketch, we just continue that line then. Okay, until that point. And then you just cut that end off. So it looks like that. So we've got a wee bit extra at the left hand side, and we've cut a bit off on the right hand side this time. Okay. So bizarrely, none of these questions exist in the booklet, which is an oversight, okay, because they definitely can come or do come up. Okay. So I'm going to give us a few questions. Yeah, I'll give us a few questions to do, and we'll take 15 minutes, 20 minutes. Okay, so oops. Try the following. Okay, so try those three. Okay, and we'll come back together at 20 past. Okay, so make sure you take a 5-minute break in there somewhere as well. So if you don't get all three done, don't worry. Just take a note of them and try to get as far as possible. Okay, but make sure you take a wee 5-minute break as well. Okay, any questions? Okay, so that's the last one there. So a few tricky things there. The negative. Okay, and where your milestones are going to be off the back of that. Okay, any questions? Anyone way off? Super. Okay. Another way similar to this that they could ask, okay, will be they will give you a graph and then you have to pull the formula from it. You have to come up with the equation. Okay, so you have to find what the amplitude is, or you have to find out what your different aspects of it are. Okay, so this is another way they could do it. So this is what I'm going to finish on. So a couple of examples of this. Okay, and then there's quite a few of these questions in the booklet. If I know what the questions are. Yeah, okay. So let's have a wee look at what I mean. Okay, so the question could ask you something along the lines of, or give you something along the lines of a graph. Okay, I'll make it nice and simple. My God. X, Y, okay. Max at 5, minimum -5. Wow. Don't copy that. Okay, so on your milestones, 360, 180, 270, 90. Okay, we get given something along those lines, and it will ask you put in the form y equals a sine x. Okay, so essentially what it's asking you to do is find what the letters mean. Okay, now that's quite a simple one in respect of it's only asking you to find the amplitude, so we're not trying to find anything else. So we're not trying to find any movement on the y-axis, the x-axis, and it's not added additional sort of waves into it. So it's just giving you one sine, okay, one sine wave between 0 and 360, but it's changed the amplitude to 5 and -5. Okay, so in this case, and I'll write it out fully so you can see it, your amplitude is found by taking the height from top, okay, or your maximum to the bottom, or your minimum, and dividing that by 2. Okay, so your amplitude is your height, your full height of that wave from the top of the max to the bottom of the minimum, okay, and then dividing that by 2. Okay, that's what your amplitude is. So in this case, it'd be 10 divided by 2, so your amplitude would be 5. Now, you should have been able just to pick that straight off that, okay, in this example, but As you know, the examples are going to get a wee bit harder. So that's the technique that you would use. Okay, you would use height from top to the bottom, and then you divide that by 2 to get your amplitude. Okay, so in this case, putting the form y equals a sine x, you're looking for that missing number, that a value. Okay, that graph hasn't been changed in any other way. Okay. Likewise, have a cost graph. Let's try and do this a wee bit better. Maximum's a wee bit off. All right, let's say 2.7, negative 2.7. Okay, and it's between 0 and 360. So all your milestones are your normal milestones. Okay, so I'd ask you to in the form y equals a cos x. Okay, again, your amplitude is what you're missing here. Okay, so your max to min over 2. Okay, so it's 5.4 divided by 2, 2.7. Again, that's really obvious off that graph. Okay, as the examples get a wee bit harder, that technique will become more and more useful. Okay, so we're just filling in the gaps. Okay, so when it's asking you, it's giving you the information and it's asking you to put in the form of that, whatever that equation may be. Magical graph. Okay. Okay, so what have we got here? What are we looking at? Okay. Every 90 degrees, we've got a full cos. Okay, so I'm just sectioning that up so it's a wee bit easier to see. Okay, but every 90 degrees, what I'm trying to draw there is a full cos. Okay, so question along the lines of put in form y equals a cos bx. Okay, what it's asking you to find out in this case is the amplitude. Okay, but also how many full waves between 0 and 360. Okay, so you've got 0, you've got 360, and at every 90 degrees, we've got a full wave repeating. Okay, so it's a case of counting how many waves there are. That fills in your B, okay, and then the amplitude is your top to the bottom divided by 2. Okay, so your amplitude, your max to minimum over 2, which in this case 4 over 2, 2. And there's 4 waves. Okay, so completing that off, we're going to have 2 cos 4 x. Okay. So we're finding what A is and what B is in this. So essentially what we're doing is we're working backwards from what we were doing in the first part of the class, okay, where we were drawing these out. We're getting given the graph this time and we're picking up key details, okay, key milestones. So a normal wave between 0 and 360, what have we changed? We changed the amplitude, okay, so where our max and min is going to be. If we change the period, so how many are going to be in that 0 to 360 space, okay. If we changed where it's sitting on the y, okay, if we moved it up, if we moved it down, okay. Okay, so a wee bit harder. Put in the form. Okay, now the A and the B are just A and B because that's the 2 missing variables. Okay, now I know B sort of moves about sometimes and that's confusing in itself, but that's the way it's going to get written in the exam. Okay, so I'm just doing it for that sake. In this case, B represents what we're moving on the vertical. Okay, so that B is what we're doing on the vertical, that y-axis. So what do we need to do here? We need to work out the amplitude, but we also need to see what we've done in regards to movement on the y-axis. Okay, if there's any movement on that y-axis. Okay, so first we'll do the amplitude. Okay, so amplitude is equal sort of from your max to your minimum. Okay, now it's a wee bit harder here because your max goes from your top, okay, and then it crosses over at this 2 line and then it continues on until -3. So you're going to 7 to 2, which is 5, and then 2 to -3. So you're going over 10 units. Okay. Over 10. Okay, so that is Okay, 7 to 2, and then 2 to -3. Okay, because we know there's been movement on that y-axis. Okay, so that halfway point is now that 2 position. So how many units from 7 to 2, and then how many from 2 to -3? So you've got 10 from top to bottom. Okay, so your amplitude in this case is going to be 5. Okay. So y is going to be 5 sine x. And then what have we done at each milestone? Well, we know it usually starts at 0, but in this case it starts at 2. So we've moved that milestone up to, sorry, my God, like my pancakes have got the back of my throat. Okay, so 5 sine x, and we're going up that vertical axis by 2 units. We're making 2 steps up. So every milestone is 2 steps up. Okay, so the maximum, if it's an amplitude 5, okay, but we're sitting at 7, so it's gone up 2. Okay. I'm choking myself to death. Okay, I'll do one more. Okay. Maybe so. Okay. Give me that. Okay. Very clever drawn. Okay. Slightly harder here. Okay, but we're going through the same process. So asking you to put in the form y equals a cos x plus b. Okay. So have we look at that, have we go at that and think about it and see what you can pick up there. Okay, so the maximum's 12, your minimum's -4. Look at your milestones and what's happening. Look at the shape of it, okay, and what's happening. Have a wee think about it and go at it and see if you can pick up where the amplitude's going to be and what the B is going to be. Okay, so I'll come back on at 4:45, okay? Okay, so that's the first thing I'm picking up there. It's going to be a negative to start this. Okay, because it's starting at a minimum up to a maximum and down to a minimum again, the opposite of what I'd expect from a cost graph. The way to find out the amplitude is still the same though. You're still going from your top to your bottom, your max to your min, and you're dividing that by 2. Okay, top to bottom in this case, You're going from a peak of 12, you're going to 0, and then you're going from 0 down to a minimum of -4. Okay, so all in, that's going to be 16. So 16 over 2. So you're going to have an amplitude there of 8. Okay, so you're going to have -8 cos x, and then what have we pardon me, what have we moved that by? Okay, well if the amplitude's 8 but the maximum shown 12, okay, that means that's been moved up 4. Okay, likewise, if the amplitude's 8 and the minimum shown -4, okay, if that is 8, you'd expect it to be -8 at minimum, but it's -4, so it's gone up 4. So we've moved that milestone up by 4 positions in the y-axis. Okay, +4. Okay, so it's all about recognizing what's happening at those milestones. Okay, and understanding what's changed about that graph. Okay. Did I lose anyone?
I did all right to the -8 cos x, but I didn't know what to do at the end, the plus bit.
Perfect. Well, not perfect, but thank you.
+4.
So that +4. Okay, so another way to think about it, if you get that amplitude, okay, so if you get an amplitude of 8 or -8, okay, you'd expect, or you'd have a max of 8 and a minimum of -8. Okay, but we've actually got a maximum, so expect that in reality we've got a maximum of 12 and a minimum of -4. So what's the difference there? Okay, so what's the difference? How do we get from there to there? Okay, so +4. Okay, so don't be scared of just taking notes, of just writing it in a way that makes sense to you and your thinking. So write out your thought process, but make sure when you do the final answer, it's very, very clear to the marker what that final answer is. So see, even the way that I've just put a box around that, that's fine. Put big stars around it saying final answer. Okay. If you want to do a wee double check after that point, that's fine. You can write as much as you want. Okay, as long as you get to that final answer in a reasonably logical way. Okay, so don't be scared to do like a wee double check. Okay, so we've got an amplitude of 8, so I'd expect a maximum 8 or minimum of -8. But in reality, we're getting them. What's happened there? What's the difference there? Well, we've moved those milestones up by 4. So what have we moved each of those milestones up by? Okay. Right. Let's call it a night. Okay. Let's call it a night. Have we got that? I've not got the booklet open. There should be lots of questions in the booklet about that. Okay, so the booklet 3, I think. Okay. Have a wee look, have a wee check. Okay, at them trig graphs. Okay, and make sense. Any questions, throw them out to me. Okay, and then we'll build on that on Thursday. Okay, so Thursday will be face to face. Hopefully you can make it. Okay, I know some people are going to be late again, so the first half hour we'll keep to that wee sort of tutorial idea. Okay, so any questions you have, send me them through and we can go through them as a group together. Okay, until everyone's there. Okay, guys, appreciate that tonight, and I will see you hopefully on Thursday.
Thank you.
Cheers, guys. Bye.